Thanks very much, everyone, and good morning. Thanks for coming along. So originally, the topic of this talk was our performance and scaling toolbox, and then I noticed that it was quite a compressed time, so I've tried to turn it into one long story for you guys, and then focusing a little bit on one part of what we've done to help our Raygun.io service scale. So for those of you that don't know, Raygun is a hosted, or cloud-hosted exception tracking tool. So it works for almost any major programming platform or environment, for example, iOS, PHP, .NET, whatever language you're using. You integrate a small little sort of component, and it pumps any of the error data that you are generating through to the service. This is really handy for developers trying to turn around fixes really quickly, as well as provide sort of almost a black box recorder for what went wrong. As most of you will know, when something breaks, half the time you'll get a screenshot inside a Word document from a customer, and it doesn't help you at all. And so we wanted to try and resolve that. So we group up errors together and allow you to sort of say, okay, well, an error might have occurred 10,000 times, but it was the same error. So we have some smarts to try and make that look like one error for you, but you can, of course, mine through the instance data as well. So I don't want to spend too long talking about Raygun specifically, but obviously if you start integrating a component into lots of different bits of software that are sending error information to a service, the volume of information that's being sent starts to get quite large quite quickly. And so we effectively were having to, we deployed the service in February last year, late last year. So it's been live for just over a year now. And effectively, we're trying to build a service that can sort of withstand, a distributed denial of service attack, because there's just a constant stream of data coming in. And to make it even more sort of pronounced, we can't do anything around where the data comes from. So, for example, one of the most popular platforms that we support is JavaScript, because people are building more and more sort of advanced client-side experiences where bugs in your JavaScript used to not matter because it just meant some animated picture wasn't bouncing around. But now, if the JavaScript's erroring out, that means your email client's not working, or your whole app doesn't function. And so we support error reporting from JavaScript, but those errors get sent to us from the client machines. So that means that browsers all over the world are constantly sending in error data. And so that sort of started out as one of those things where we released the service and we went, okay, cool, we're getting, I don't know what it was from memory. Let's say it was about 500,000 data points a day with error information. And we kind of went, okay, and we've got a bit of capacity for that so we can grow and all of that. And then this leads me to the story that was about, must have been about August, I guess, last year. Yeah, this is the story. And so we had this potential customer get in touch with us and say, oh, we think we're going to send a bit more data than your top plan supports. And our top plan supports about 2 million exceptions being stored. And I said, okay, cool. How many errors do you expect your software to throw? And they said, oh, about 6 million errors a week. And then there's a part of me that is an engineer, whenever I have these conversations with people where I'm kind of like, seriously, 6 million fucking errors a week? Like, ever thought of fixing this stuff? And so we did this negotiation on price, and they plugged it in, and it was all good for about a month or so. And then one night I was just at home doing some work, and I was watching the dashboard for the Raygun site, and I was actually on the phone at the time. And effectively what happens is that the error data comes into Raygun and it gets queued. And then we have worker processes that pop things off that queue and sort of do that grouping and send out the notifications and all of that sort of stuff. That queue typically sits at about 0, which is good. And I just happened to open up the admin dashboard and I was like, 900,000 items on the queue. It's quite a few more than normal. And I just sort of sat back and kept talking on the phone for about another, I think the dashboard updates about every 5 or 10 seconds. And sort of did its update, and it's like, 985,000 messages on the queue. And I was like, oh God, what's going on here? And so I rang up my business partner, Jeremy, and was like, something's a bit funky here. Something's not going quite right. Somebody's sending a lot of error data to us. And so he jumped on, and we're all hosted on Amazon, so we started using CloudWatch to monitor the amount of data that was coming across the Elastic load balancers. And effectively, this is the graph that we kind of had, which was the volume, the wall of data that sort of started turning up all of a sudden. And so it turned out that as we were doing a little bit of digging around, that it was this customer that thought they would send 6 million a week. And they were sort of blowing through their 6 million in a matter of minutes, because what they hadn't told us is that they were using the service to migrate from V1 of their product to V2. And I knew that they were large, but to put it in context, they're about 2/3 the size of Twitter in terms of active user base. And it turned out that almost every interaction with their new system caused an error. So we had this as a bit of a problem, and we'd kind of, like I say, we'd always made sure that we had a bit of capacity and all of that. And so this was what led me to put together this presentation about how did we handle this sort of onslaught. And of course, I'm the business guy at Mindscape. The last thing that I want to do is ring them up and say, yeah, go away. I'm like, hey, this sounds like we could bill them a whole lot more money. So first off, we started trying to work out what was actually going wrong. Where was the system failing in various ways? So the first thing was that our web app couldn't read. And so here's a sort of dumbed down but sort of overall architecture of how Raygun was designed. And so you'll see up the top there, well, effectively the front thing there is the Elastic Load Balancer, and it sort of sprays data off to the API nodes, and then that data gets queued. We were using Redis for queuing, and then the worker picks things up off those queues and then decides what to do with it. So we had MySQL for stashing some of the data, Elasticsearch for the search engine, and S3 as a sort of cold store of all of the raw data that was coming in should we ever need to do something with it again. And the top box up there was sort of the application website. So people that went to app.raygun.io to log in to see their errors. And the problem here is that could no longer read any data because we'd built the API to be shared. Okay, so we thought, well, okay, API is API, we'll put it out front, and we just, the app is nicely built using Backbone and Marionette, and so it makes all sorts of API calls to load the data into the app, and it was calling against those same API nodes. So first quick fix was to kind of go, oh, well, we don't want all of our other normal customers that aren't sending us this many errors to have a bad experience with the product. They shouldn't feel the effect of that load when they actually log in and look at their data. And so our first quick fix there was to quickly pull the read API away from the write API. So it was a mistake to sort of keep them together at the get-go. And so that solved that problem. Now, if you were also a Raygun customer at the time, you could actually log in and use the app. So that was the first problem we solved. Second one was Mono was self-harming. So who here has written a web app using Mono? Okay, I see like one hand. Yeah, it's not the world's best thing to do. Mono itself is kind of cool. I like the idea of an open source .NET that runs cross-platform and all of that. But the issue is that we have a lot of .NET skills, and we wanted to host it on Linux because we didn't want to have sort of spendy Windows boxes there. And there's also, given the nature of Raygun, which is kind of a DevOpsy style tool, we knew that there was lots of things on Linux that we wanted to be able to use as well as what we were writing our code in. And so we had these two API nodes at the start, just for some redundancy, running Mono for the web API, sorry, not web API, just the API. And what we found was that it just leaks memory like crazy. Like, if you actually go around and you start Googling and you kind of go Mono, web, memory leak, you just find all of these threads spread over the years of people going, yeah, it's just leaking memory everywhere. So not only does it leak memory, but as you can imagine, when you start throwing hundreds of thousands of requests at it, it leaks memory really, really fast. And so we ended up where we went from these two servers, and we had this really kind of cool graph that as Jeremy was adding in additional API nodes, all that would happen is that box would get saturated, 100% CPU, Mono spewing memory everywhere until it fell over and got recycled again. And so we ended up where we needed 12 of these boxes to handle this load, and kind of have this rule which We weren't happy. There was only one person that was happy that we needed 12 boxes, and that was dirty old Jeff. And so we were like, we can't really afford to spend on 12 boxes where 10 of them are just for one customer. This is really inefficient and not working very well for us. So what we did was we'd prototyped about a month earlier building the API endpoints in Node. And the reason that we'd picked Node was because our API is actually ridiculously simple. Right? All it does is it gets the data in, it checks to sort of vaguely validate that it looks like something that's intended for Raygun. So it checks that the app key is valid, and then it checks a couple of other things, and then it more or less puts it on the queue. Right? And so this works really, really well with the event loop sort of structure that Node.js has built into it, where we could actually scale it up quite a bit off a single instance. And so to put it in comparison, we ended up where we went from those 12 mono boxes back down to 3 Node.js boxes with 60% free capacity handling that load, which was quite a monumental amount of difference. Now, we could have absolutely put in more time on the mono stuff, but the fact that it was sort of leaking memory and nobody seemed to really be that keen in the wider community to resolve that sort of put us off trying to spend much more time going down that rabbit hole. So Node.js solved that problem. And so this led us to the last major problem in handling this wave of data, and that's that we had MySQL in the mix. And so I say it's a locked party at MySQL's house because basically the rate we were trying to write at it and people were trying to read from it, it just pretty much would lock up on its own locks trying to do work. And so I think we've got it here. So that last piece back there with MySQL, we were like, oh, this is really not working very well. And we were using Amazon's RDS service, and the reason that we'd started off with that was because RDS is really easy to work with. You can, they automatically are handling your backups. You can do multiple availability zone support for it really easily. All the sort of good things that you want when you're starting up a new product, but you don't want to have to put too much time into getting it working. And so we were looking at this problem with data storage and sort of going, how are we going to fix this one? And let's take a look at Elasticsearch, because what we found was we noticed that we were able to write to our Elasticsearch instance, which we only provided for paying customers who were paying extra for search, fairly well. And it was actually coping happily with the writes, but MySQL wasn't. And so we'd set up this cluster of 3 nodes, and it was working really well. And we sort of went, well, we only put Elasticsearch in because, like the name says, it was a search product, right? And that was the first sort of mistake. And I'm not a big fan of the fact that they call it Elasticsearch, because it does search great, but it's actually become much more of a sort of a big scalable data store, which is pretty cool. So I wanted to do a bit of a demo and walk through today of some of the stuff around Elastic, because ever since we decided to start moving some of our data into it late last year, we keep running into these scenarios where we kind of go, oh, this thing's now a bit of a problem in Raygun. And then it turns out that Elasticsearch has something built in that just perfectly handles what we're looking for. And so who here's actually worked with Elasticsearch in production? So not too many people, but it's really cool. So I'll jump to my demo here. So first off, I'm running Elasticsearch just on my Mac here. It works happily on Windows, Mac, Linux, no problems at all. It's written in Java, which we can forgive it for that sin. And it works really, really easily. So when you first set it up, you just basically run up this script. It manages the sharding. It manages being part of a cluster spread across multiple nodes and all of that stuff really easily. You can index data super easily. All of this stuff just works. That's also a bad thing about Elasticsearch. I could do a whole talk on Elasticsearch where I could discuss some of the challenges that we had with it early on. Where because it just works, often those defaults that it starts with are actually not very good when you get to production. And I'll hit on some of them as we go. So first off, the primary way of interacting with Elasticsearch is through its REST API. And so I'm using a an extension for Chrome here called Postman. Who here has used Postman before? Wow, more popular than Elasticsearch and Mono. Good times. Okay, so for those of you that don't know of it, it's a free extension. You can grab it from the Chrome store, and it's really, really handy when you're working with anything where you need to be throwing requests to test out some code. So I'm going to use it today for throwing requests at my local Elasticsearch instance. And so what we have here, and I've shrunk this down because it takes up a bit too much space on the screen there. It keeps a history of the queries that you've run. And then up here, you give it the URL you want to go to. You can change between the different type of action that you want. And since we're doing a post, you can also then throw in the message that you want to send. So in this case, what I'm going to do is I'm going to index a piece of data. And so here, what we've got is this JSON blob. So I've just set it up as the app name, version, the error, and of course you can handle all the nested stuff as well. That's fine. And so that's what also makes it really easy to work with Elasticsearch. There are some strong typed API wrappers out there that people have written. I know that there's Nest is the one for .NET that everybody seems to use. And there's, if you go to the Elasticsearch page, there's wrappers for just about every programming environment there is. That'll make life a little bit easier, but on the whole, it's pretty easy to work with to start with. So what I'm going to do is I'm going to post to localhost on port 9200, which is the ES default. Then you give it an index name, so I'm going to call the index raygun, and then you give it a type name, so call this error, and this will be ID 1. And so if we send this, that doesn't work. All right, let me just flip over here and make sure that I'm actually running my, no, maybe I'm not running Elasticsearch at the moment. Let me see what we've got here. No, okay. I'll just fire it up. Where did I actually put it? That's a better question. Sorry about this. I think it is in my oopsie. Let's go into here. Sorry about this, guys. I closed one of the bash tabs before because I was like, oh, I'm actually remotely logged into a server, and I was like, I should probably not leave that there. Okay, so we run this guy up. It'll give us a name by default. It's actually kind of amusing to me that this here is the name of the server, and it randomly generates this every time you start it up. So that's actually different from last time. So that should now be running. Let's jump back here, and let's just see if this guy runs. Cool. Okay. So we sent that, we get a little response there saying that it's gone, the things that are prefixed with an underscore, they are effectively the internal bits of data about what we've done. So we know the index and the type and the ID. You'll see there that it's version 53. Now it's version 53 because 53 times I've pushed something to ID 1 while I've been practicing this demo. And obviously it took the 53rd time for me to try and do it without running Elasticsearch. And so you can see there that it didn't bother creating it because it was an update. Now, what we can also do here is actually pull the data back. And so if we change this to a get and we run the same thing, you actually get that data back that we pushed in plus the extra metadata about it. So it's all really, really simple to push some data in and pull it out. And what it's doing behind the scenes here is it's building out a mapping file. So this is, in some ways, you could think of Elasticsearch as being a schemaless data store, but it actually does have an implicit schema, which is the structure that you've actually sent through here, okay? And so this was one of the ways that we screwed up when we first started with Elasticsearch, is we were like, wow, this is really great, it just works. But what it will do is, let's say version just had the number 1 in there. Elasticsearch will see that the first time and say, I'll build, and they don't call them schemas, they call them mappings. They'll say, I'll build a mapping where when I see the structure, I see version, and I expect it to be an integer, right? And then the next time I send it something like this, and it goes, oh, that has to be a string, but it will say, well, I've already got a mapping which has version as an integer. I can't index that, which is a problem. If we added in another field that came through, it would quite happily add that field. So it's additive, but you can't update the mappings. And the problem with this is that your mappings can kind of explode if you senselessly start throwing all sorts of random data at Elasticsearch. And 9 times out of 10, unless you're changing that fundamental type information, it will happily play along until you start wondering why it needs, ungodly amounts of RAM to operate, and it starts to slow down. So understanding that what's happening with the mappings was our first little hitch. Now, I won't go too much more into it, but just so you know if you are playing around with it. It kind of reminds me of back in the day when I tried playing with Ruby on Rails, and every person who plays with Ruby on Rails, they jump in, they go, oh, what's this scaffold command? And they're like, holy crap, this made me an app in 2 minutes. This is the best thing ever. And then you talk to somebody who's about a week into knowing it, they're like, yeah, never use the scaffold command. It's a great way of getting you started, and it lowers the barrier to entry, but nobody's doing serious work with it that way because that's not how you want to manage it. So the next thing is, obviously, let's look at the fact that there's search in the name of the product. And so over here, not that one, let's go with this one here. I'll just minimize him back. So what we're going to do is we're going to run a query here. You can see that we just throw the underscore search on there, and we can give it q equals marathon. And if we send this, we get the usual sort of internal stuff. I mentioned before that Elasticsearch, it is a product that has built-in redundancy, support, and scaling. So you can see here that we've got talk of shards, but we never actually have to really worry about them as a developer. And you can see here that there's a total of 712 documents in my Elasticsearch instance under the Raygun index of type error that actually have the word marathon in there. So there we go. Ian did not join me in the Wellington Half Marathon this year after I almost killed him last year. And you can see here there's some search-related things like what's the max score and all this metadata, but effectively you're getting this collection back. There's obviously things that you can pass into that query where you give it paging information or however many items you want back. But simple querying is very, very simple. You can then also look at information like, for example, we've got version here. So we might say we want to query where version equal colon, and let's say 1.1.2, 1.2. We could AND together here to say both of them, and you do that. It matches 712 again, but you can also do things that you'd expect to see in search like this, where if we send that, we now get 1,000 results. So it works very naturally with how you'd expect to be able to query things, which is cool. A lot nicer than writing SQL, in my opinion. But where we start to get some other ones, though, is if we start looking at faceting. And so what do I mean by that? So this is where you do a query. So you might say, I want to see version 1.0, and now I want to also pull out some extra information on the result set that's going through. So let me show you with an example here. So I'm going to go down here. Where's this guy? And so this time we're doing a search with a post, okay? And we're providing this extra information about the facets. And so what we're doing is we're saying we want to look at the version field, and we want to learn more about that field. So I'm using what's called a term facet. So if I send this and we scroll down, we get the usual result-related stuff, but we get the summary at the bottom where we can say very quickly, we have 712 items of version 1.1.2, 278 of 1.2.1, and 10 of 1.1.0. Now this starts to become really powerful because if you start thinking about it back to how you work with SQL, you're effectively doing things like a group by, but being able to also get aggregate information at the same time. And you can do it all with a very small query, and it's super, super performant. There are people out there that are running Elasticsearch instances that are petabytes in size, and getting great performance out of it. And so we started to look at some of the things that we were doing with Raygun. And again, I mentioned we started initially looking at Elasticsearch as a data store, And then we started going, oh, hey, there's all these other problems that we can actually solve with Elastic. And so I thought I'd jump back to the slides at this point to sort of try and paint a better picture of one example where it wasn't just the data storage. And this was the filtered charts. So if I jump you back really quick here, and we go and have a look at this slide here, you see the chart at the top there? And so that's the errors that happen on my website, my personal website, jdtrask.com. It only gets about 3 visitors a month, but it throws a lot of errors because I'm using a really, really crappy WordPress theme, and when Googlebot turns up, it just starts exploding all over the place. But you can see that that graph there is sort of up and down all over the place, and there's a little version filter drop down over there. And so what we were doing is we were using Redis to store the time series data for the chart. So as we processed errors, we would sort of kind of go, okay, we plot a point for the hour. But we don't update the chart when you change the version filter. So if you released a new version of your product and you just wanted to see the chart with the information for that version, we couldn't do it. And the reason that we couldn't do it easily, if I jump back down here, is because this is effectively the structure that we had in Redis. Every hour we would basically have an app, ID, stats, and then time bucketed by the hour, and we'd increment the number of items that we'd seen. And so then we sort of said, okay, well, what if we wanted to also have the version information stored? So version 1 per hour and version 2 per hour. Well, suddenly we've doubled the amount of memory that we need to store that data. Redis is memory-based, so we basically need to keep expanding the amount of memory. And then one of the things that we constantly get with Raygun is people saying, now I also want to see it by operating system, or if it's a web app being monitored, I want to see it broken down by URL or user, and all of this stuff. And you start, or combine them all. And we sort of sat there scratching our head going, man, this is, we can't actually do this with Redis in a smart way, because we would have to have every combination of everything that we wanted to be able to filter on. That's going to take up way too much memory. It's also kind of stupid. Is there something we could do here with Elasticsearch? And so I've just showed you before the term facet where we got the aggregate data about a given value for a given field. There's actually a whole pile of these facets that are available in Elasticsearch, and the one that we wanted to use for the charting was called date histogram. And so that actually allows you to say, hey, given this query, say the application where the version is this and the operating system's that, give me the effectively the data to build a histogram from this of the counts that occurred in those time buckets. And it also happened basically instantly coming out of Elastic. And so we could build up all of these different things. We didn't need to store so much data in memory. And we give a lot of more flexibility to our users, and it just works. And so I'm a bit worried at the moment, because as technologists, we always have those moments where suddenly we think a piece of technology is a silver bullet for everything. But thus far, I'm really struggling to run into too many things that Elasticsearch has actually done badly for us, and it hasn't helped us with. Other than the fact that when we got started, we made a bunch of dumb decisions that hurt us as we scaled up. So I would strongly encourage you guys to take a look at Elasticsearch. I repeat what I said earlier, that I think the fact that the product is called Elasticsearch is a mistake, because I think most of us would probably look at it if we were tasked at work with building a search engine or adding search, but we wouldn't necessarily think about it when it comes to just needing a really good, fast, high-performance, scalable data store. And I'd encourage you to take a look. So that kind of brings me to the end of my talk today. And I'd like to open the floor to any questions if anybody has any. I saw that my piece of paper was held up at the back, but I couldn't actually see whether it was 10 minutes, 5 minutes, 1 minute, but I'll take a question or two. Anybody?
Are you still storing your data anywhere else? Do you still put it in MySQL, or do you put it all in?
We still store everything in S3, and that's more just a case of every now and then we want to do something with the data historically that's come through. So we might want to replay that data into a new data store, or we might want to be able to run a test with something and simulate it with real data. So we always have a copy that's stored privately on S3 for us. We still use MySQL effectively just for the user accounts, and we also have the grouping information. So I mentioned that we sort of roll up the errors into a group. So if you had 1,000 instances, you'd have one group with 1,000 instances next to it. So we store all of the instance data in Elasticsearch now. We still store the groups in MySQL, and that's because that has other state information against it. So you can mark it as resolved, or you can permanently ignore. So for example, if you get errors on your website that are generated by spam bots, you're never going to fix that. That's not something that's wrong with your system, and so you want to permanently ignore that. So we store that sort of state still in MySQL. But in the grand scheme of things, you're talking about a difference of like, I don't know, maybe 1 or 2 gigs of data in MySQL versus, I think it's close to 1 terabyte of data sitting in Elasticsearch now. So it's still in the mix. There is a little part of me that wrinkles my nose at MySQL, but we'll get rid of it one day. Any other questions? No?
To handle 1 terabyte, how many instances do you run?
At the moment we have 1 instance across three boxes, so 3 nodes in the cluster. We are looking at expanding that slightly, but for now we're probably actually going to just move the boxes up in their capability first before we increase the actual box count. 3 is about the minimum number of boxes that you want for Elasticsearch for the way that it does its sharding, so that at 3 you can have one of the nodes fall out of the cluster and it will still continue to operate because all of the data is still available by default. That works well. One of the things that, again, we almost made as a mistake was to actually have some of those nodes in other data centers. The Elasticsearch guys are working to try and make that so it works well, but for the moment the latency often causes a sort of a split brain to occur if there's too much latency between the nodes. Because obviously longer term what we'd like to do is have, say, part of the cluster in one availability zone and part in another, so that, although I always joke that the upside of hosting with Amazon is that if it ever goes down, people are too worried about their own stuff being offline that they don't notice that you're down. But yeah. Anything else, guys? No? I can't see any hands. Thank you very much for coming, and I hope you enjoyed the talk.